Hello class, this video is an overview of the Boyle's law and Gay-Lussac's law lab. So if you go to Blackboard under labs in the left menu, you'll see there is a folder for Boyle's law and Gay-Lussac's law. So if you click on that folder, I have kind of instructions for you, and since we are not able to do the experiment, I found simulations that you can do the lab online and merely collect the data and use Excel to make graphs and submit the report back to me. And here also I included a couple of videos to help you understand the Boyle's law and Gay-Lussac's law. So I think they are helpful videos if you start watching these, and they will help you also prepare for the class. After you complete the lab report, similar to what you did in the paper chromatography, you come back and submit it here. We'll come back to this. So again, this is one link. I'll share this with you in another screen, but before we do this, let me show you how to submit the lab report again. So when you are ready to submit the report, just click on the last link here. And as I said, you click and browse my computer, and then you pick whatever file you have, and just attach it. And again, in this case, you only have one. Whatever graphs you have, I suggest that you copy the graphs from Excel and attach them to the same report, so you only submit one report to me. If you are not able to do that, you could submit the Excel sheet with your lab report, but I don't want you to do that. But again, if you decide to do that, make sure to upload all of your files before you click on the submit button. So let me go back and share the sheet with you. So take a minute to share it with you. Okay, so this is how the sheet looks like when you download the sheet. So these are this is the first simulation that you need to do, and I'll try also to access this online and to show you how it works. So basically, you just push that piston and just change the volume and take the reading on the pressure gauge here. You are doing it twice. You are doing it first time with air, and then you are doing the experiment second time with oxygen. And our original lab report use air and natural gas, so that will be similar. So mainly you just change the volume and make sure to read the volume with the significant figures, and also read the pressure, and you need to put your results on this table here. So this is the pressure, this is the volume, and this is calculated one. So mainly this is the inverse of the volume, so just 1 over whatever you have here. So 1 over this, 1 over whatever you have there, that will be the inverse. And then in the Excel sheet, you need to draw the pressure with the inverse of volume, not with the volume, so that the pressure should be in the y-axis, and that the inverse of volume should be in the x-axis. And do this graph and just attach it to this sheet here. And you do the same thing as I said for the second one. You just change it to oxygen instead of air, and you collect the same kind of information. So you take the pressure, change the volume, which is the volume, read the pressure, and do this, calculate this calculation. This is not from here. You need to calculate it yourself. For the second part, for the Gay-Lussac's law, this is another simulation. So make sure to click. I mean, this one you could do the 3 of them, but I just chose different simulation. So make sure to click on the Gay-Lussac's law in the top. And for this one again, you could we are going to change. So you have temperature and the pressure. So you play. Can you change this arrows? Just pick 4 or 5 temperatures and make sure they have a different range between them. So change the temperature and take the pressure reading. So mainly you make the change, you change the pressure, the temperature, and see what will happen to the pressure. So that's mainly what you need to put here. So you collect the temperature in Kelvin, the pressure in atmosphere, and then you have to calculate the temperature in Celsius yourself. And you know that temperature in Kelvin equals Celsius plus 273.15. So do the math and find the temperature in Celsius. And the same thing, you need to draw a graph for this one. So you need to put the pressure on the y-axis on the Excel sheet, and the temperature in Kelvin, not in Celsius, in the x-axis. So that's mainly what you need to do. You may have issues with starting the simulation, so I put some troubleshooting here. So depends on which browser you are using. If you are using Google Chrome, so that's mainly you just click on that. If you get empty graph, so it needs Adobe Flash Player, so you just click on that and allow that Flash to run. I think that should be fine. And then if you are using Microsoft Edge, it will be the same. Just you need to click on this icon here and then allow the Adobe Flash if it doesn't work for you. So either one of them, you should be able to run it in one of them, I assume. And let me see if I can also show it to you on the browser. So just give me a minute to share my other screen. Okay, so this is I'm using Google Chrome here, and you can see the simulation did not work. So it asked me here, click to enable Adobe Flash Player. So just by clicking there, I get this message, and I just allow it. When you click allow, it works there. So then, as I said, you can just push that cylinder up and down, and that will change the pressure. So maybe you have to let me try to make it larger so you can see it. So you can see you can just change the pick a volume, and again, like don't just say 20. So this will be kind of 20.0 if you put it exactly at the line. Maybe 20. So that's mainly you have to decide what are these numbers, because this is in 5. So that will make it harder for you to know. So this is from 5 to 10. So this is kind of 7.5. So 5. Maybe do this 5, 7.5, 10, 10.5, 15. So that will be easier for you than trying to figure out something in between. And just when you read the pressure, also don't just give me 20. So try to estimate like the same thing. So like this is 15. So each mark here is 1. So 15, 16, 17, 18, 19, 20. So you have to estimate between the lines there. And then so this is for first one. Then you change it to oxygen, and you do the calculations calculation yourself. And actually it give you can see it, you can pick points, and it will show here. So you could take the readings from there. So that's even better, because it give you 2 decimal places. So let's say if I want a 20, just take it to 20 and it will change. Then I take it to 15 and they dropped. So that will give me the 3rd point. And then maybe 17.5, and then 15. So either way, so just pick something and copy these results to your lab report. Okay, let me show you the other simulation. Let me just give me a minute again to share my other screen. Okay, so this is for the other application. So again, make sure to click on Gay-Lussac law. So you could actually do the other one here, but I just chose different simulations so you could learn from both. And again, here you just can see this is the room temperature. So you get just change the temperature. At room temperature, it's 1 atmospheric pressure. Then if you increase the temperature, so just can just keep increasing the temperature and see, yeah, maybe like this one, and just take the reading. And this unit here is in atmospheric pressure. So this is in Kelvin and atmospheric pressure. And then maybe do another temperature. Yeah, you can pick 5 points or so. So that you got the idea here. So maybe and you could add a point that it will show you the points in line here. So and then you calculate, and then you could add another point, and then you calculate. So that will show you the points, but and you could actually take the reading also from the table, like 0.1, 0.2, and 0.3 and 0.4, and you could try this another time and pick different points. Okay, hopefully this thing should be easy. One for you should be able to do this, and when you are done, just submit the lab report back to on the Blackboard. If you have any question, email me. Thank you.